Okay, we were talking about the factorial, and factorial also a recursive function, right? And then there is the definition for recursive function. It is the 3-point definition. Three point one. Factorial function. Factorial. Function. There is a two case A. If n is equal 0, you know, this is like coding, then n factorial is equal 1. If n is greater than 0, then write n factorial is equal n times n minus 1 factorial. So if you follow that condition, I mean that method, here is the given A and B case. Is recursive, right? And it is refers to itself. It refers to itself. Okay, end of the lecture, I will take your question about the midterm. Refers to itself when it uses n minus 1 factorial. And 1, the value of n factorial is explicitly given when n is equal to 0. Thus 0 is a base value, and 2, the value of n factorial for arbitrary n is defined in terms of a smaller value of n which is closer to the base value 0. So let's think about the example. Okay, this is page 7, and let's write the example. Okay, example. Let's say we have Let's say we have 4 factorial is equal what? So this is the question. So according to, algorithm we wrote here, let's see, look at again definition 3.1 as a factorial definition. We will write as a 4 factorial as a solution of that one. 4 factorial is equal 4 times 4 minus 1 factorial. So actually, instead of 4 minus 1, we can write here directly 3 factorial, right? So it's going to be, easy to understand. Okay, good evening, Emre. 3 factorial. So for 3 factorial, I can write here as a 3 times 2 factorial. For 2 factorial, I can write here as a 2 times 1 factorial. And then for 1 factorial, I can write here 1 times 0 factorial. So what I know for 0 factorial is equal 1. This is what I know at the beginning of the case A, right? If n is equal 0, then n factorial is 1. So I got that point for my solution. So I got that one. 0 factorial is equal 1. So I will go back and I'm going to put here as a 0 factorial is equal 1. 1 factorial is equal 1 factorial is equal 1 times 1. It means 1. So I know 1 factorial is equal 1. There was the 2 factorial. Or you can go back. I don't know. This is the representation of your book. I'm taking 2 factorial. I know there's the 2 times 1 factorial, and 1 factorial is equal 1. This is the 2. So now I came that point as a 3 factorial. 3 factorial is equal 3 times 2 factorial is equal 2. Here's the 6. And then I came where? There is the 4 times 3 factorial is equal 6. And here is the 4 factorial. So I will get a point as a 24. This is the recursive function. As you see, I came to point, separating the my value as n factorial is equal n times n minus 1 factorial, and then I found the 0 factorial and go back. So this is the recursive function, and how we solve that recursive function. We get that point and then we go back to our footprint, then we came that point again. So next one as a Fibonacci sequence. Fibonacci sequence. So this is the really famous and well-known sequence. Okay, there is the Fibonacci sequence. I will jump to definition. I will write directly sequence. There is the 0 starting with the 0 and then 1. This is the known two term of the series or sequence. After that you will do summation of that two term and you will have 1. Then summation of that last two term, then right here 2. Last two term summation is a 3, and summation of 2 and 5, 2 and 3 as a 5. And what else? 3 plus 5, 8. 5 plus 8, 13. 13 plus 8, 21. And 34. 13 plus 21, 34. And 55, and so on. If you add 89, something like that, there is more. This is the Fibonacci series, and we know that f0 is equal 0. First two term, yes, Sinan, 0, 1, 1, 2, 3, 5, 8, and 13. f0 is, starting point. f0 is equal 1, and first term of that sequence. And we know that f1 is equal 1. Then rest of the dots sequence coming from that point. And there is also kind of algorithm to produce the new term of that series, and how we can define that sequence. Of course, there is the definition. Okay, let's write the definition for that sequence as a 3.2. Like the factorial definition, here is the Fibonacci sequence. Again, there is the case A, if n is equal 0 or n is equal 1, then fn is equal n. If there is the 0, here is going to be 0. If there is the 1, n is going to be 1. So next one, this is the mentality of the algorithm to produce Fibonacci sequence. And if n greater than 1, then what is the explanation? Fn is equal Fn minus 2. I'm sorry, 2 is a little bit higher. N minus 2 plus Fn minus 1. So this is the idea what is behind the Fibonacci sequence. So there is also definition recursive definition. Since the definition refers itself, right? Like the recursive to itself, when it uses f minus 2, f minus 2, and f minus 1. So it is referring itself using that two terms. And there is the new recursive function. There is the new recursive function as a Ackerman function. Okay, Ackerman function. So what does it say? So the Ackerman function, there is the explanation. So this is also well-known and famous function, and this is also, recursive function is a function with two arguments. There is the, more than one argument, each of which can be assigned any non-negative integer and that, you know, that is 0, 1, 2, something like that. And also definition. So we saw this is the third definition and this is the second one. And can you see the colors in my screen? No, you can't see, right? Because we reduced to stream. If we increase the stream, there's gonna be color. Yes, no? No, we can't see any color. It's black and white. Okay, let's reduce to streaming. Anyway, now we are 6. Alper Furkan, Batuhan, Bilgehan, Emre Erdin, Navidur Rahman, Sinan Eker Biçer. Okay, we were talking about the Ackerman function. So there is the definition for the Ackerman function. There is the A if m is equal 0, then we have a condition again. Then AMN is equal n plus 1. For that condition, if m is equal 0, there is going to be m plus 1. So next one, if m is not is equal 0, but n is equal 0, for that case, then increment sequence or function AMN is equal a m minus 1 comma 1, and see if m is not is equal 0 and n is not is equal 0, so this is the last condition, then our function is equal a m minus 1 comma, there is the a, you know, it is refers to itself, a m n minus 1. So this is a little bit maybe strange when you compare the previous one is a Fibonacci series and factorial recursive function. This is the little bit different. Okay, is there any example? Anyway, maybe in solve problem, there is the example I'm looking for. Okay, there's the, yeah, there's the example. I want to cover some definition instead of the example, and you get the definition for Ackerman function, and I write the cardinality, and then algorithm functions. Yeah, almost we are coming to end of that chapter. Any question? Any question till now? I will write some definition for the cardinality. Dear friend, Sinan, you have a question about the midterm. But one also, same point. You want to, is that a fast growing function? You mean the Ackerman? Okay, we will come that point, I think, as a big O notation. Sinan. Okay, Batuhan. Batuhan, did you complete your sentences? I think Batuhan touched the keyboard. No, he's writing something. Yeah, you are in midterm. You are not in, our definition. But you have to wait. And cardinality. Okay, cardinality. What is the cardinality? Sinan, do you have any idea? What is the cardinality? Okay, there is no answer. Any of you? Do you have an idea for cardinality? No. Okay, let's try definition and talk about cardinality. Let's say there is the two sets, A and B are said to be equipotent. So or to have the same number of elements or the same cardinality or same cardinality. So cardinality is the what according to that definition. So we can represent A and B have same cardinality. Actually, we have to write code in that lecture. At that time, it is gonna be more valuable. But now we are just talking about some definition and theorem. Corresponds f a to b, there is a function. So how about you? rest of you. So what do you mean? You mean asynchronous sound and movie part, or I mean video streaming, or any other something? Okay, you are stopping to write. You are giving one comment, then that's it. So let's write. We have a table. Here is the student ID lagging ID, and we have a set of student ID. We have student name, student last name. Okay, student last name. So their class, first year, second year, and third year, something like that. And then did you hear that sound? Okay, class and course. Courses passed. So I have that table. Yeah, there is a fighting of my voice. I'm sorry. So if I doing that kind of online lecture, they're starting to fighting. So student ID, for example, there is the something like that 01 XX and XX 02. I don't know what is the X or, and there is this student name, let's say Emre, and last name Ardin, and second year, right? Emre, are you second year student? Okay, second year. For example, course passed, like what? Second year, you mean 7/7/14, maybe. Okay, there is the Ahmed. Is there an Ahmed here? No. Okay, there is no Ahmed. Okay, last name. And okay, he is third year. Maybe he passed like 17 course. And what is the name? Okay, Alpar. Alpar Furkan. And image. And what is the class of yours, Alpar? And there is the student again here, XY, I don't know. Okay, her name is Ayşe. Last name is maybe okay, only good. Okay, this is the again second year in 14, and so on. Here is the third year and 19, something like that. So if you write the set of student ID, what do you think you will have here? How many ID is here? And then number of student IDs is equal, let's say, for our table, you know, our universal set is going to be our table, maybe our university, but we don't know. Maybe our department, let's say 200. Okay, I don't know. Do you hear me, Emre? Okay, I did student name. Did you lost any connection? I mean, you have any connection problem? Student number and student name. There is the names of the students. And what do you think about the number of student name? Emre, do you hear me? For example, 150. And student last name. What do you mean R? I see. Okay. There is the what? Okay, can you attend that? You know, there is the really problem. I agree you, because sometimes I'm feeling something is really fast. Sometimes there is a something freeze or stuck. Okay, can you join that link? This is the Zoom share. How about that one? Emirhan. Emirhan is in Zoom. Can you write what is the, what can you say? How about now? Is it better? Okay, this is better. You can follow that link. If you want, there is the UBIS. If it is better, you can follow from the UBIS. I don't know. You have two chances. Alper said this is the better. You know, I was writing the table and I choose inside of that table as a column is gonna be one set. Okay, thank you, Emre. Here is gonna be one set. If you look at the ID, there is the 200. If you look at the name, there is the 150. And last name, for example, you look at the last name in that table, you saw what? There is you can't say exactly. Okay, let's say there is exactly 200. Last name and ID has same what? Cardinality. So this is the point actually. And you did as a class. There is a set of class we can write easily. There is the, 2, 3, and 4. There is the 3 type class. Then you can say, and class is easy. There is a 3. And cardinality of that class is 3. Or uniqueness. I don't know. You can say uniqueness. And you see there is a student ID and last name giving you like the exactly same cardinality. So this is the meaning of the cardinality, and I can jump that one. Any question? Question? I open also, Zoom, and I'm waiting also in UBIS, which is working. I'm gonna answer. Both is open on my computer. There is no question. Okay, next title, and I will stop here. Algorithms and functions. So this is the next title, and I will stop here. And you have some question, I think. I can answer your question, but one was writing some spatial, something. What you were saying, but one, and you forgot to write some answer, right? So there is no solution for that situation. I'm sorry. Any question? Alper, Emre, Sinan. All clear. All clear. How about midterm? Everything is clear for midterm? It was the really, really simple and basic exam. And there is the, there's nothing to do question for you, because we already start the function chapter behind our, some point that I missed, hocam. You mean for the cardinality or midterm? Okay, I'll stop to record the lecture for UBIS and also Zoom. Then if you have a question, you can open your microphone and say what you have in your mind.